Hi, welcome to lecture 1 in the series of 8051 programming and interfacing. In this particular series or in this particular tutorial series, we'll talk about 8051 programming and in assembly and as well as in embedded C language. We will also talk about how to interface 8051 microcontroller with other subsystems like DC motor, relay, IR sensor, GPS module or GSM modules by writing programs based on embedded C or assembly language. So this will be a 10 to 15 lecture series, and this is the lecture 1 in that series. So in this particular lecture we'll talk about the introduction of 8051 microcontroller, or in other sense the basic introduction of the microprocessor. So if we start about the microcontrollers, so the first thing should come into the mind, like what was the need of the microcontroller and what are the various applications where these microcontrollers can be used. So the thing is, in early 1940s or 1950s, or we can say 1960s, there were systems to control motors or to control in a sense automatic door opening systems. So there were systems like discrete component based system. So discrete component based system means we have a IC of NAND gate, we have IC OR gate, or based on these gates IC we are making a system for performing a specific task. That was the general purpose. So the requirement was needed to change, or if we have a discrete component system, so if there is some requirement, there is a change in the some requirement or some specification, the problem was we need to change the entire system, entire circuitry needs to be changed. So the it was a requirement was felt, or it was a sense for a requirement like we should have a system in which if we change just a programming or just in a sense just the instruction to the system, so the every functioning of the system should change based on just by changing some instructions of it. So this idea leads to the invention or leads to the creation of microcontrollers or the microprocessor. So this particular idea which we talk about, like where a specific instruction to be performed residing in the memory, and our specific system or a different subsystem is reading those instructions one by one, and based on those instructions the particular CPU we can say or particular core is performing certain actions. So the same system can be used for door opening, the same system or same small system can be used for DC motor control, same system can be used for temperature control, and so on. This was the general idea. So based on that we come across with the two different configurations of the systems, and these two configuration further leads to the in the difference between microprocessor and microcontrollers. So the first thing comes like before going to the microcontroller, how they are different between the microprocessor. So when we talk about microprocessor, we talk about a general purpose microprocessor like Pentium 4 Core 2 Duo i3 processor or ARM processors or so on. And when we talk about microcontrollers, those are 8051 PIC based Atmel microcontroller, Atmega 16 microcontroller, or Motorola microcontroller. So the first question comes like what is the basic difference between this microcontroller and microprocessor? So if we talk about from the hardware point of view, microprocessor is a bigger thing. It has everything as a separate unit. So we have control unit or the CPU as a separate core, and USART communication protocols, memory, input output interfaces, timer or counter, or other peripherals like controlling a DC motor, controlling your keyboard. Everything is a separate IC, and we have only single IC that is known as the microprocessor. Like if we talk about Pentium 4 or Core i3, so this is a single microprocessor unit. and every other thing which need to attach a separate IC for that. While in the case of microcontrollers, CPU, timer, memory, clock, input output interfaces, USART, other peripherals, all those subsystems, separate other subsystem comes on a single chip. So here we have different chips. Here we have a single chip, a complete system, and every other IC, whatever the requirement is, that is on chip. So obviously this particular microprocessor are meant for some other general purpose application, or the bigger applications, like we are running a operating system on it. So we can't run operating system on microcontroller because it has a specific these microcontrollers are designed for a specific requirement with some constraint on it. So they have constraint of memory, they have constraint of input output interfaces, and so on, while we have less constraint as far as memory and other things are concerned with the microprocessor. So this was the basic difference in it. So the requirement is, when we say the operation of a system changes with respect to the program which we are writing, or with respect to the instructions which we are providing to it, then those systems are known as the embedded systems. Embedded system includes, like we are embedding software with the hardware, and based on the software your hardware change its functioning. So these microcontrollers are the heart of those embedded systems, and these embedded systems we mean like they are specific for a particular task. For example, lift controller, door opening controller of a lift or any automatic system. You have a data logger embedded system where you are logging the data of the environment. You have specific small hardware for controlling the speed of the DC motor, that also example of the embedded system. And then this microprocessors are for the general purpose, like computers, mobile phones, and bigger embedded softwares like missile control system, etc. So this is the general idea, like why we need these microcontrollers and how they evolve. So this particular lecture series is specifically about 8051 microcontroller. So we will learn about it in further detail. So this 8051 microcontroller was first designed in 1981 by Intel Corporation, and then there are several other companies which follows the same. So the idea is the basic internal architecture, or the core of the 8051 architecture is same, while different companies produce different variant of it. They may have more than one serial port, more memory, less memory, depending on the requirement. They can work on different oscillator frequencies, but the core structure, like instruction set, remains the same. Number of input output ports remains the same, and data bus and address bus remains the same. So every other thing remains the same, while several small modifications were done as per the requirement. So if we have a general block diagram of 8051 microcontrollers, then it looks like this. So this is the general block diagram of a 8051 microcontroller. It has a CPU, it has a there's a central processing unit, it has a inbuilt oscillator. For that we need to apply a crystal oscillator at the output pins of the microcontroller, which is used to provide the clock. And we will, this is just the block diagram, we will go into the further detail of each block in the next lecture. And then it has a on-chip ROM. This ROM contains the data memory as well as the program memory. That means the program which you are writing in terms of the instructions, those particular program is written inside this ROM. And also if we are using some specific data to be like a table, or like a table to store some kind of results, we also use this particular memory. Then we have a RAM for the CPU. So for this 8051 microcontroller, so specifically this 8051 microcontroller has 256 byte of RAM. Out of this 256 byte of RAM is divided into two parts, a lower 128 byte of RAM and the upper 128 byte of RAM. So different registers used in the CPU are stored in the lower 128 byte of RAM, while some special function register like accumulator, B register, different ports addresses, and different registers for timers and serial port communication, or different register for program counter, stack pointer, are stored in the upper 128 byte. And we will go into the further detail of this RAM, because that is particularly important when we talk about the assembly language based program, writing assembly language based program for 8051 microcontroller. Similarly, we have input output ports. Input output ports means if we want to interact with the outside world data, then these input output ports are used to send the data outside world and to receive the data from real world or outside world inside the microcontroller. So these are ports, you can think of, they act like hands or foot of the microcontroller, and it is like a brain of the microcontroller. Similarly, this serial port is used for communicating with the other devices, like this one controller is there and it wants to communicate with the another controller with another subsystem. Then 8051 microcontroller is equipped with the serial communication port, that is USART port, Universal Synchronous Receiver Transmitter. Similarly, it has two 16-bit timers, and those timers are particularly used for providing delay and for providing the clock for this serial port. Similarly, it also has interrupt control, so it can provide, it has different kind of interrupt, internal interrupts as well as the external interrupts. It has two external interrupts and 5 or 6 internal interrupts related to timer, serial port communication and other functions as well. So this is the general block diagram of it. Now in this first lecture we'll talk about a general, we'll try to induce the general feelings to learn microcontroller and some of the basics which are important in the further part of the microcontroller. Similarly, okay, we have gone through it. Now just wait, let's have what other things we can discuss. We have talked about embedded system. Yeah, now the last thing which we'll talk about, we want to keep the lecture as short as possible while providing the maximum amount of data, by providing maximum amount of information to you. The next thing which comes when we start a microcontroller, there are some of the basic concepts which needs to be clear, which needs to be understood clearly prior to further learning about the microcontroller. So one of the instruction or one of the concept is about the buses. So when we talk about bus is a collection of wires in terms of electronics or in terms of embedded system. That means if we have more than one set of wire, like 2 wires, 3 wires, 3 or 4 wires are clubbed together, then we call it a bus. So in any microcontroller, if we talk about specific to the 8051 microcontroller, we have 3 different kind of buses are there. That is control bus, address bus and data bus. So we generally don't care about this control bus, it happens automatically. But this address bus and data bus needs to be understood in detail. Address bus, data bus is used, or the wires which are used to transfer data from one area of the microcontroller to the another area of the microcontroller. Like there is one register accumulator and we want to move the data from accumulator to some other register of the microcontroller, then this data bus is used. Similarly, address bus is used to find the address of a specific location inside the memory of the microcontroller. This is the most important concept, address bus, and which generally confuse our students. So we will spend some time over here in the bus, and we will and then we will end for the first lecture. So let's open Paint and have some thing. Now when we talk about data bus means we have this kind of registers inside our microcontroller. That means each memory location contains 8 bit of microcontroller. So when we talk about like our 8051 microcontroller is a 8-bit microcontroller. We will say it is a 8-bit microcontroller. That means the size of data bus is 8-bit. That is data bus size. Data bus size means memory or any information which can be stored or which can be transferred in single clock from one side to another side, that can be of 8-bit only. That means the data size or the number of wires which are clubbed together, those are 8 in numbers. So any memory or any register is like this. So it has 0 from if we talk about little endian, so this is your LSB, lower significant bit, and this one is your MSB. And whatever data is being read or write, or whatever operation is happening inside the microcontroller, that is happening in the digital form. Digital form means we have either 0 1 1 0 1 1 0 1. So if you are weak in digital electronics or an understanding like how to convert this digital code, so we will suggest like go through some basic of the digital conversion, like how to convert binary to hexadecimal, hexadecimal to binary, and what is the significance of these two, and how to add. So this is the binary number. So most of the time we will be writing into hexadecimal format, and either that is data or memory address. So it is so it is mandatory to understand how this is happening. So if we say we have a register and this has this much of data, so if we want to convert into hex, just make a combination of 4 4, and this will become 8 to 10 and 11. So 11 is C, 11 is B, and it is 6. So this number is B6 in hexadecimal. So think about it as a memory location now. So either this memory location could be of RAM, ROM, or any other thing. Now we'll talk about this was about the data bus, and if we delete entirely all these things, so the wires which will be using to carry this information. So if it is a bus, there will be wires which will be used to read or write the information on. So there will be 8 wires, and the value of these 8 wires will determine what will be the data inside the location, and the bundle of these 8 wires is known as the data bus. So there are 8, so this is 8-bit data bus. Now when we talk about address bus, so let's change it. In this previous slide we were having one memory location. Now think about, we have a series of memory locations where we are storing the data. So it is a kind of vertical rack. So this is rack 1, this is rack 0, rack 1, rack 2, rack 3, rack 4, and so on. And in each rack there is a separation of 8 bits, right? So now you can understand the previous slide which we discussed. We talked about a one location, and now we have several locations stacked together. So this is a memory structure, and each location has a unique address like 0 1 2 3 4 5 6 7. Obviously this is could be in decimal or hexadecimal. Now, and there will be lines out there, these will be data bus which are connected to the memory, and this is 8 in size, so it is a 8-bit data bus. So whatever memory we will access and the data present in the data bus, that data will go into that particular memory location. So this was about data bus. Now think about another line. Suppose we have a wire, single wire, and it is connected to by NOT gate to here and here. Now this is a single wire. If we talk about this is known as the address decoding. If we have put a 0 here, here will be 1 and here will be 0, so this particular address will be selected. And if we put here a 1, we put here a 1, then second address will be selected, and whatever the data is there, that will be available on the data bus if we want to read that particular memory location. If we want to write it, so whatever the data is present at data bus will be returned inside the memory location. Now from single wire, it is clear we can access only 2 address, because it has only 2 states, either 0 or 1. So if we have 2 wires, now the total combination which can go on these 2 wires are 4: 0 0, 0 1, 1 0 and 1 1. So similarly in the internal, this address decoding circuit, a different circuit will be involved, and based on that, if we are presenting 0 0 on this line, this particular address will be selected. If we are basing 0 1, this address will be selected, 1 0 this address, and 1 1 this address. So if we have 2 wires, we can address 3 different address. So address means the memory locations which we are targeting, because ultimately in RAM or ROM, these are the memory locations like I said. Now if we have 3 wires, we can have 8 memory locations. We have 4 wires, we can have 16. We have 5 wires, we can have 2 to the power 5, 32 different addresses, and so on. So suppose we have n wires, so we can have 2 to the power n different addresses. So this is the total address which we can access by the n number of wires. Okay, so the address bus means which we just discussed here, not here, which we just discussed here. So this address bus again a collection of wires which are connected to the address decoding and then connected to the memory location, so that whatever data we will provide here, that particular address will be accessed at the memory. So if we say, if we have write I hope you understand it, and 8051 has 16-bit address bus. As we just discussed, 8051 microcontroller has 8-bit data bus, because it is a 8-bit microcontroller, and it has a 16-bit address bus. So you can understand how much total address, 2 to the power 16, and it comes out to be 64 kilobyte of data can be accessed from the 8051 microcontroller in one go. So let's have a new slide. So if we are writing like we are providing an address of like 0x10, this is in hexadecimal. That means its number is, if we talk about 0x10, it is like 1 2 3 4 5 6 7 0 1 2 3 4 5 6 7 8. So it is 0 0 0 1 0 0 0 0. So we can provide what memory location which we are accessing, that is 32nd, because from 0x, not 32nd, we are going 16th memory location. Sorry for that. We are accessing 16th memory location if we are providing this data at the address bus, right? Similarly, we can write like if we are providing 0x4f. So similarly, you can also find like which particular memory locations we can accessing, which we can divide like this. So it is 0 0 1 0 1 1 1 1. So you can convert this binary number into decimal, and that from that particular decimal number you can access okay which particular memory location which we are adding. So ultimately in hardware the data is propagating in the binary form, but the hexadecimal form is just for the sake of the representation to understand by human beings. Like we can't every time write like this much of long code. So if it has a 32-bit number of address bus, then these bits will be 32-bit long. So instead of that, we can use this hexadecimal number to provide the addressing to the memory available of the microcontroller. So this is how we can differentiate between this address bus and data bus of the microcontroller, and the difference between these two needs to be understood prior to go learning any other microcontroller or a microprocessor, if we want to understand it from deep down process, like from the beginning. So, and we will learn further like how to because this particular concept will also be important when we will be learning about the memory locations further in the next lecture. So in next lecture we'll talk about the internal architecture of a 8051 microcontroller in further detail, and from I think third or fourth lecture we will start doing programming and start doing interfacing programming with 8051 microcontroller. So I hope you understand a lot from this tutorial video. So if you have any doubt or any suggestions like related to the content or anything, you can tell us by writing the comment below, and please subscribe to our channel for more such videos. So that's it for this video. Thank you.